In this video, we will discuss the elements of an experimental type project. All projects in the experimental category should include these elements, though of course they will vary greatly from project to project. You can find more information about these elements on the Calgary Youth Science Fair website, CYSF.org, under the Frequently Asked Questions section. To help explain what these different elements mean, we will be using made-up project about soil erosion as an example. So, for starters, you're going to want your background research. Each topic should start out with some background research. This helps you understand more about your topic and can help you come up with a problem or testable question to investigate in your experiment. It can also show you what sort of research other people are working on in this area of science. This might include what factors in general can affect soil erosion, what soil is made of, why soil erosion is an issue, and where in the world would soil erosion be a problem. Next, you're going to want to find your problem or testable question. The problem or testable question is a specific question that you want to investigate in your experiment. For example, the question in our example experiment would be, how can soil erosion be controlled? After you have a question or a problem, you're going to want to move on to your hypothesis. Your hypothesis is what you think will happen in your experiment based on your background research. You'll design your experiment to test your hypothesis. You should write your hypothesis using the if-then, because format. So, your hypothesis should read, if grass and daisies are planted in separate containers on the same slope angle, then the grass will prevent erosion better than the daisies because grass shoots will grow more densely spaced and hold the soil in place. Now that you have your testable question and hypothesis, let's move on to the variables. In an experimental project, there are 3 different types of variables. It's important to know what they are and what they mean to your project in particular. The first type of variable is a controlled variable. A controlled variable is the quantity, value, or state that is held constant throughout the experiment. These are the things that you keep the same in the experiment. For example, the time for growth, temperature, and amount of water given to plants may be some of the controlled variables in this experiment. The next type of variable is a manipulated variable. The manipulated variable is one quantity, value, or state that is purposely changed in the experiment. This is what is changed in order to see what happens in the experiment. For example, the manipulated variable here is the type of plant, grass or daisies, planted in the container. And finally, the last type of variable we have for an experimental project would be a responding variable. This variable is a quantity, value, or state that changes when a variable is manipulated. It's basically the result of changing the manipulated variable. Here, the responding variable will be the amount of soil eroded in the containers of grass and daisies. The last bit of planning you'll need to do is make a list of the materials you'll need for the experiment. For example, for this experiment, you might need 9 plant trays, daisy seeds, grass seeds, and water. Now it's time for the real hands-on part of your project. Make sure to take careful note of your procedure. The procedure is a step-by-step explanation of how you did your experiment, including the number of trials and sample size in each trial. You should do at least 3 of them, meaning the whole procedure conducted 3 times to show the reproducibility of results. A good sample size would be, for example, 3 containers of grass and 3 containers of daisies per trial. Once you're finished running your experiment, you should record your results and observations. Collect your data, whether this is qualitative or quantitative, and record it in a logbook. Then summarize the data in a table or graph. Make sure your axes are labeled correctly and the units of measurement are indicated. Finally, you'll come to your conclusion. Your conclusion is the final outcome of your investigation as confirmed by your data/observations. Your conclusion should prove or disprove your original hypotheses. So be sure to refer back to your hypothesis as part of your conclusions. To finish up your experimental project, you should include applications and extensions. You should be able to explain why people will be interested in knowing your results and how they can use them. Show why your experiment would benefit people or how they could use your knowledge to make something better. You should also be able to explain how you would do your experiment differently in the future or how you could improve upon it if you were ever to do it again. For more great tips and information about the Calgary Youth Science Fair, make sure you check out our website at cysf.org. You can also follow us on Facebook, Twitter, and Instagram.